Okay, guys, a few things we need to know about what we're going to be doing today. First of all, can anyone tell me what this is? Sorry? It's not Python. This is not Python. This is Voronoi, yes. Voronoi. This is what the majority of architecture students do when they open up Grasshopper for the first time and they're like, I want to make a fancy pattern. They put a note called Voronoi, they connect it, and they go, oh, this is the most amazing thing in the world because it allows me to make some funky shapes. So some of you had some tutorials on paneling tools, and what was the other one? I'm not sure, you guys. Yeah. Lunchbooks? Yes. Yes. So that program as well is very similar to this, to Voronoi, right? So what it does is it has a preset amount of patterns, let's say, and you're just going by what that program has, and you're just selecting it and applying it to your own design. When you learn Python, you don't have to follow anyone's patterns. You can create your own. Okay, so what Python allows you to do is have the freedom to do whatever you want in terms of shapes, in terms of structures, in terms of everything. Whatever you can imagine and have the, I won't say the coding capacity, but the mathematical knowledge to generate it, then you can do it. I'll show you some examples now. So things we're going to be going through next week, and I apologize in advance for this week being a little bit more text heavy. So if we go into the modular design, so well, actually, let's change this back. This is a script that joins random points. We can arrange the points however we want into a modular structure. You can use it as an interesting space frame structure if you have a very curved or very complex shape that, just drawing it up becomes very difficult, very complex. Well, if we were to, it's loading, give it a second. If we were to just create a Python script that has a recursive way of joining points that are a certain distance away from each other into a coherent structure that's modular in nature, then we can create all kinds of stuff. We can create shapes like this, right? I'll show you the initial points so you know it's just a random populate 3D. So it's a bunch of points that are randomly there. We can make them as arranged or as random as we want. Really, that's not the point. It's more about what we can get out of them. We can get them to seem like a little bit more like a space frame structure. And we can make it even more advanced if we really wanted to. Really simple tools, by the way. This is not the complication. And if we wanted to make it even more complicated, we can change the degree by which the joinings happen. Let's make it 2, so you can tell the difference. Just by a touch of the button and a little bit of waiting time for it to process, because obviously you're running complex mathematical equations and it's having a hard time. There we go. We can create more interesting shapes, right? How cool is that? How long would it take you to draw a modular space frame structure that's very straight lines into something like this? A day? Well, it took me like, what, 5 seconds, right? So that's what Python allows you to do. It has the freedom to do whatever you want, as long as you can imagine it and make it happen, which is another issue on by itself. You can do it. We can create subdivisions. This is one of them. It was just a straight edge, and we can do some funky things with it. We can change the amount of divisions to make it more or less complex. We can change how much we distort the shape if we really wanted to. Rotate it inwards on different angles. Make it really funky if we wanted to. It's up to you. So, more freedom. And if we go to the woolly paths algorithm, we can take a bunch of straight lines with, whatever, in whatever shape we want, whatever straight lines we want, run a simple algorithm to determine, this is called the woolly path algorithm. And then after we've done that, actually generate form out of it that we can use. This can be used at an urban level, not necessarily just at a facade or anything on the level. So yes, so these are cool things that we can do with Python. You can make the most incredible facades. We can make our most complex building structures work, right? Without having to resolve to specialist engineers. So yeah, that's the freedom. So what are we going to do today? Well, we're going to start by learning Python. So we're going to start with the basics, okay? Super simple stuff. Every Python script that you will ever encounter and every coding script that you will ever encounter is based on these fundamental things that I'm going to teach you today. They're added up in different orders. They might seem complex in nature, but it's the same stuff, okay? It's literally the same stuff. And every language that you use also is made up of the same stuff. The only difference is the syntax. So it's like, I don't know, the difference between speaking English and Spanish, for example, right? So, you know, it's the same, it's saying the same things, but in a different way, using a specific order by which the words go in. So yes, if you learn one coding language, you can pick up any other very easily. And if you learn the basics of any language, you can decipher the most complex scripts. Does that make sense for everyone? Good. All right, we're moving on. First things first. Accessing Python Grasshopper. Not difficult at all. Super easy. You all have Grasshopper open? Yes? Okay. The only thing you have to do is literally double click inside that empty space and write py or gh Python, whatever you want, until you get this gh Python script and press it. That's it. That's all you have to do. And you have access to Python in Grasshopper. Everyone done that? Yeah, everyone have a Grasshopper node? Okay. If anyone has any issues, at any point, tell me and I'll come around, okay? But unless you tell me, I am going to assume that you're all following. If you do get lost, do raise your arm because, you know, if you get lost at some point, you know, we want you to be able to catch up. Okay, so let's add some inputs and outputs to our code. So what I want you to do is create something called a panel. So if you double click inside Grasshopper again, type in panel, do that twice, and connect one of the panels to something called X on the Python node and the other one to the A of the Python node. Can anyone guess what the X and A stand for? Yes, inputs, outputs. So X is basically one of the inputs and A is one of the outputs. You can, if you zoom in, actually, you know what, let's just do it together. Might be easier. Let's just take this script and create a Python node here. Can everyone see on this? No, you can't. Okay, whatever. Exit this. Okay, so right, everyone can see my screen. I'm just going to zoom in real hard. Can everyone see the Python script that I have here? On the side of it, there's these pluses and minuses, both ends, okay? That's what allows you to add and remove inputs and outputs, okay? So let's say if I want to have 3 inputs in this script, I just do a plus here and it comes up with a Z as well. We can rename them. So if you right click on them, you're allowed to rename them. You can name them whatever you want, you know, you can change that Z into something else. Let's say, I don't know, let's call it data. Doesn't really matter, but you can see there, it's called data. And the output's the same, so you can add more outputs if you want and name them whatever you want. Important thing to note is that if you're adding and removing inputs and outputs, those are referenced within the code. So if you have something called data coming in, right? So we have the data here. When you tell the computer that I want you to read this input, you have to say it's read whatever name you have there, you have to reference it the same name. We'll go through it in a bit. Don't worry about it. I'm just, because we're naming it, we'll have them here. So yes, I've just asked you to add a couple of panels, one panel on one side, one panel on the other side, on the A and the X. Super simple stuff. So now we have some inputs and some outputs. Doesn't really mean anything because we haven't really done anything, but good. It's the start. So let's continue. Right. So a few things to note about coding. The order by which we write the code matters. Because, computer reads from the top to the bottom, same as you guys. When you read a book, you don't start from the end chapter and go to the front chapter, or the middle chapter and go to the end, and then start from the start again. You start from the top and you go down. Okay, so the computer is going to read the code from the top to the end. So it's very important because sometimes you have a piece of code that technically everything that you've written down is absolutely correct, but because of the order by which you place things, the computer is like, I don't understand what you're trying to do. Okay, so it's a very logical thing, and it's trying to understand you, but we have to help it sometimes. Okay, so just keep that in mind. So the first thing we're going to think about now is data types. I'm going to write a lot of silly jokes. Just go with it, okay? Right, so variables. What are variables? Variables are very important. It makes it easy for us to change the same values we have in our code by changing just one line. It's also one of the most common way of storing data within our code. I know it sounds very difficult, but you'll see now. I want you to type this into the panel that's going in. The panel that's going into our X. Double click on it and type this in. There once was a man named George. He was 70 years old, full stop. He really liked the name George, but didn't like being 70. So I've just asked you to just make this bigger because we're not going to be looking into that. We're going to be looking into that. Just double click in here and copy whatever I wrote down, which was this. There once was a man named George. He really liked it, but he was 70 years old, and so on and so forth. Has everyone done that? I'm going to zoom in a little bit so you can all see what I wrote down. So everyone with me so far? Everyone wrote that down? Yeah? Okay. Let's go back to here. So if you wanted to change the name George, for example, to John, you have to manually change it in the panel, right? But if you had variables, you didn't have to. I know this is a very simple thing. And in the grand scheme of things, changing the name George to John is very easily done by double clicking on the panel, but you're going to have some more complex things that you may want to have in a variable that allows you to do that. So how to manage data? We're going to use a variable to store our character's name and age. So step one, we have to give a name to the variable. So there's two things we have to do. First, we're going to name the variable, character's name, character's age. Done. And step two, we have to give the variable a value. So what is that character name and character age equal to? So let's do it together. Okay, so remember how I told you how you can change the variables names for the inputs? Yeah, we're going to do it together. So we're going to create two inputs, character name and character age. Right here, I have them here. I'm just gonna right click and say, okay, this is gonna be my character name underscore name. So never put space when you're naming a variable because the computer thinks it's something else. Okay, so a name given to a variable can have no spaces in between. When you use an underscore, like I have done there. And then the other one would be character age. Okay, so we're going to create a couple more panels. And we're just going to join them up in here like this. And we're going to say, okay, so this panel which is connected to character name. We're gonna say it's George, that's his name. And character age, well, he's 70, so I'm just gonna write 70 on there. Now, a couple of things to keep in mind. And this has to deal with what it is that we're putting in. What is text called in coding language as a data type? A string, yes. So this is a string. Numbers are integers or floats. Floats is if it has decimals. And true or false is called a Boolean. So these are the main three data types that you're going to be familiar with. This is a string, okay? In Python, in Grasshopper, we have to tell it that our input is in fact a string. So when you right click on, let's say, character name, forget about the item access, list access, and tree access for now. We're going to go through it a little bit later. If you go into type hint, it comes up with a ton of different things down here. str is string, right? So we have to select that and tell it, in fact, what I am giving you here is a data set that's actually a string. So then the computer can understand that, okay, so this is a data set and it's a string. So I'm changing all three, including the top one, which is X, into strings. Everyone okay with that? Yeah, simple stuff. Just right click, type hint, string. It's actually quite helpful to tell Grasshopper what data set you're inputting into the Grasshopper nodes, because sometimes it thinks it's a geometry when it's a number, or it's not very smart. Let's just call it what it is. Right. Okay. So let's go a step further. So how do we add it to the code? A is our output. Okay. So I'm telling it that our output is equal to quotation marks means string. The once was man named and quotation marks plus character name, which is our variable, plus quotation marks again, our format stuff. Can you write that down and tell me what comes out when you press test? So if you go into the code, let me show you. If you go into the double click the Grasshopper scripts and you come up with this, okay? When you go here, can you type in that top line inside and press test on the top right? And tell me what it comes up with. There's no way decimals. All right, okay. You know what? I'm gonna add it myself. I'm gonna zoom in here so you can all see it. I don't think I can zoom in anymore in here. Can I? Is that good enough? Can you see at the back? Okay, so all I have to do is say A, which is our output. So if I go here, you'll see it's A here, right? Is equal to open quotation marks, because this is indicative of that what I'm going to tell it is a string, and say there once was a man named space plus I want my character name to go here, plus open quotation marks, full stop. He was. I'm not entirely sure what I told you to write was, but it doesn't really matter. Character underscore age plus years old. Full stop and quotation marks. So I'm gonna expand it a little bit so you can see the whole thing. Okay, can you all see that? Yeah, guys at the back. Yes, okay. So just type in A is equal to this. Type it in exactly as I have. You should have the red lines and the, everything should be the same for you guys. Yeah, so if you named character name or character H with a C capital or an N capital, it has to be the same. Okay, it is case sensitive. So you typed it in, you pressed that play button on the top right there. What comes out in the end? Okay. Did you all do that? Did you all write that down? Can you all see at the end? So if I press play up here, can you all see this coming out as your exit panel? Yes or no? No. Why? Okay. So everyone done that? Yeah. So what did we learn? What did we learn? We created a variable, right? And we told that that variable is actually going to be inserted in the line of text right there. So what does that allow us to do? What happens if we change George into John now in the input panel? Change it. What happens? You'll change in the output automatically. How cool is that? You don't even have to think about it. Yeah, really, really good. Okay, let's move on. Yeah.
Spaces.
Yes.
Within the string and outside the string.
Outside the string, they're not really necessary. Okay, sorry. So a string, okay, is a collection of data. The space is actually a data input within that string. So when I leave a space within the quotation marks, after names, for example, I leave a space, it's because that space is counted in the output. So it will leave a space after names so that I can put George, okay? So anything within a string, spaces count. Anything outside a string, so this class character name, if I don't have a space between them, the computer is fine with it, It's just for our eyes that it looks easier. Does that make sense for everyone? Okay, so let's move on. Basically, the only thing we can do to add it to our code is just write whatever statement we want plus that variable plus the other statement, right? So you'll have a challenge to do now. You need to change all the names and ages in the print statement to variables. So in the entire print statement, which is here, there once was a man named George who was 70 years old. Let me just zoom into this for the people at the back. Can you all see that? Can you see that at the back? So I want you to change all of the names and ages into variables. Yeah, make it work, make it come out with that outcome. So, yes, basically break this up and add variables where the names and ages are. Come on, we already did half of it. We should be able to continue the other. All right, so a couple of things to note down. As Mahmoud says. Let's go back to the code. How do we create a variable? We give it a name and we give it a value. Okay, so let's say I wanted to create the variable, I don't know, MSA underscore students, right? To just have the value of how many students we have at the MSA. All I have to do is give it a name and make it equal to whatever value we want. I don't know, we have 1,000 students. I just write 1,000 in there. It's fine. Okay, that's how you create a variable. What I've done here in Python and in Grasshopper is I've done the same thing, except instead of writing it in the code, I've created this variable so that I can change from outside my code the values, because Grasshopper allows you to do that. But essentially, this character name and this MSA student is the same thing. They're both variables. And the whole point of a variable is that it has a name and it's equal to a specific value. That's it. Now, when I say that A is equal to this, A, in fact, is our output, but A is also a variable in this situation because A, I'm creating this variable which exists here as an output, right? The reason why I name it A and not anything else because it's corresponds to this. So if I wanted to name it, I don't know, give me any words. Let's call it Bob, right? If it was Bob, right? If I press play, it's not gonna do anything. Why? Because A is not the same as Bob, is it? It's like, okay, A, I've created this new variable, it has this thing in there, but have no way of displaying it. So if I change this now and say that, okay, this is now Bob, and I press play, there you go, we're back on track. Does that make sense as to why that A is there and so on and so forth? You can name it whatever you want. It doesn't really matter.
A way to signify what
Yeah.
the name of the data or the data stored in it. And the equals to is not a mathematical equation. It's tiny.
It's, yeah,
So
you're basically.
data, save it in this name. Then you can access the data into the name.
So this is more of a reference point. The variable is a reference point to access a particular set of data. The data can be anything. So everyone with me so far? Everyone able to add and remove variables? Okay. Let's move on. Okay, so basically that was the answer. So I'm gonna just remove this for now. You know what's cool about variables? You can do anything you want. You can change the value at any point as many times as you want. It doesn't matter. And you can even change that value midway. So halfway down our code, I could tell it that character name, right, changes into something else. And it'll go, okay, character name changes into something else. And it changes that value. It just changes the way that it references it. So you can do that. So how do we change the variable name to be Mike? How do we do that? Yeah, change it in the panel, write Mike. I mean, how simple is that? Right, there you go, Mike. Make him 35, do whatever you want. So let's go a little bit backwards. What can we store inside a variable? Well, there's strings, which is basically plain text. So a string, you require these quotation marks in order to signify to the computer that this data is a string. Numbers, right? We have 50, 50.241 or whatever you want. That's a data set that you can put in there. And Boolean values, true or false. An example is, is male is equal to true. That means that, the variable is male is true. Remember to use underscores when you're trying to add a space in between. You should never have a space between variables. Doesn't work. Some of you have done that mistake. Okay, let's have a little bit of fun with strings since we've started working with text. This is just so you can get used to a few things. It's easy, maybe. So in our Grasshopper script, let's make a new one. Let's make a new one because this one's forget, doesn't matter. Let's just make a new script. So double click, write g8 script, make a new one, open it up. Don't worry about adding anything in or out of it. And just copy what I have here. Type phrase is equal to American Academy in quotation marks. And then type A is equal to phrase and put a panel at the A at the end. The reason why we call it A is because Grasshopper in Python in Grasshopper always has A as an input by default when you make a new node. A is equal to phrase. So guys, come on, super simple. So let's do it. So here we write phrase is equal to American Academy, and A is equal to phrase. Let's add a panel at the end. Whoop, big panel. Display. Oops. Spelling mistake. There you go. Okay, has everyone done this? Right? Okay, what happens if we write, instead of a space between American Academy, we have \n. No, \n. Come on, what's the difference? Sorry? Yes, creates a new line. It's basically just telling it that it's like your enter button in a line of text. So in order for the computer to understand that you want to go down the line, you write no, is it backslash? It's \n, and whatever you want to write, right? So it goes to the next line. Does everyone get it? Yeah. Cool stuff we can just work with. I mean, that's all. I mean, don't worry about it if you don't understand it fully. It's commands that we can write. So what happens if we write, instead of \n, quotation? What happens? So when you press play, does it work? Yes. Yes. So you can put quotation marks inside the quotation marks. Because if you did it otherwise, it'll just mess up things. So you need that \. Basically, the \, it's almost like a shortcut command to something else. It's telling you that, okay, when you see this, I'm doing something crazy with the text. Okay, so everyone with me? Cool. Let's do a little bit of like a little bit cool. So what happens if you say A is equal to phrase.lower and open and close brackets? Yes, do it. Write it. A is equal to phrase.lower, open and close brackets. Don't worry about it. Mine is different than people. So, okay, guys, A is equal to phrase.lower, open and close brackets. Has everyone done that? Very simple. What happens? All lowercase. So, okay. What is that dot lower? Does anyone know? It's a function, yes. So it's a function that allows us to kind of tell it, okay, so you know this, do this to it. Okay, just giving it a function. All right, let's see how much you got. Challenge number 3. How do you change your variable to all uppercase? Come on. Yes. Yes, phrase.upper. I mean, if phrase.lower is all lowercase, phrase.upper must be uppercase, right? I mean, come on. It's all right. It's very easy. Did everyone do that? Yeah? Okay, let's go on. Let's play a little bit more. What happens if we put phrase.isUpper open and close brackets? The first one. Phrase.isUpper open and close bracket. I'm going to zoom in even more for the people at the back. False. What does that say? Why is it false? It's a Boolean, yes. Yes. What is it checking? So if it's checking if it's all caps, yes, you're telling it. Is it all uppercase? Right? Check, please. And it's saying, no, it's not all uppercase because only the first 2 letters of each word, sorry, only the first letter of each word is. What happens if you type A is equal to len, open brackets, face? Yeah, len. Yeah. What's the output? What's that 16 stand for? 16 digits. Does it count the space?
Yes.
Yes, it counts the space. So it's telling us that there's 16 pieces of data, string data, right, that are within phrase, a variable. Okay, what happens if we type in A is equal to phrase square brackets 0? Gives you the what? The alphabet. The first digit, yes. So what it gives you is the first piece of data within phrase. And the first piece of data is, as you know, number 1. So computer starts counting from 0, not 1, 2, 3, 4. It's called 0, 1, 2, 3, 4. So A, which is the first letter that we have, the first piece of information, it's that. Okay, oof, electrocuted myself. Everyone with me so far? Everyone having a little bit of fun? Okay, let's continue. This is what I was telling you. So indexes is what the computer calls items within a list. Starts counting from 0. So A is equal to 0, M is 1, and so on and so forth. You're going to be using this a lot, especially in Python and Grasshopper, when you're going to be opening up your panel. Even if you don't use Python, when you open up your panel, it starts showcasing all the information that you have from 0, 1, 2, 3, 4, because that's how a computer starts the list. Right, cool. Index function. Okay, type this in. A is equal to phrase.index, open brackets, A, capital A, quotation marks, close the brackets. What happens? Yeah. Uppercase, yeah. This upper is just a boolean. It's checking, is everyone not perfect? Because it's checking at, because, yeah. Yes, but we changed that. Yes, but is it now? Exactly. You haven't changed the original data. Just know that case. I'm going to give to an instance of that data set that I just saw after. But then you're asking me to change that the original data set. No, if you do phrase dot number, remove A. So just type in E, phrase dot number. Just tell that, yeah, just remove that. So remove the space. And the first test. And so you analyze the value of that variable. Now okay, so let's move on. Let's move on. Sorry?
Pick the second name.
The second item from the index.
2 ways.
You'll go through it, don't worry. There's other functions. Okay, guys. What happens if you do A is equal to phrase.replace, open brackets, American, comma, CPU? What happens?
Let's see. From 0. Position of the last.
Okay, so what happens if you write this down? Yes, it replaces American to CPU, right? I'm just telling it. Please, from that phrase, replace this piece of data with that piece of data. The comma, it's basically one is one parameter of the function, and after you have a comma, is the second parameter of the function. So in replace, you have two parameters. The first one is what do you want to replace, and the second one is what's going to be replaced. Okay. Challenge, I think it's 4. I gave up on numbering after this. Use the replace function to print African anatomy from the original phrase. So change American Academy into African anatomy. So to try and replace it so it comes out with African anatomy. Has everyone done it? Yes. How do we do it? Yeah, you can use replace. Yeah, I mean, you can be inventive in this. You can do A is equal to trace.replace AME with AF, and then replace again Kade with Nido, if you want to really shorten it up. Oh, yeah, zoom in. Yeah. The really complex and intricate people in the room would change specific letters to that, but you know, for everyone else, they can just go and say, you know what, change the whole American into African, change the whole academy into anatomy, and go to just you know, fuck it, let's just do that, right? Why am I bothering? Fine, it's absolutely fine. Anyways, correct. If you wanted to completely do it correct, well, I mean, what you could do is just say that phrase is now equal to African anatomy and just update the value of it and just be done with it that way if you really wanted to. But you see how many ways we can do it. Right. Working with numbers. So we're going to move on from strings, create a new Grasshopper Python node, and let's play around with numbers. Numbers is more fun. It's maths. It's cool. So in our new node, which I'm going to create as well. Well, actually, I'm just going to delete this part because, yeah, it's whatever. You can see it here. Let's start doing some cool stuff. Let's just say A is equal to 2. I'm going to be needing your help here because you're going to have to tell me what comes out when you type these numbers in, okay? So when you type in A is equal to 2, what comes out in the panel? Come on, shout out. 2, the number 2. Right, okay, so it understands that it can read numbers. What about if you type in A is equal to 2.0987? Come on. What happens if you type this in? A is equal to 2.0987. The same value? What that 2.0987? Yeah. Well, see, the computer can read decimal points. Really good. What about if A is equal to minus 2.0987? What comes out? The same? Minus there. So it can read negative numbers. Brilliant. A is equal to 3 plus 4.5. Come on. 7. Come on, guys. Okay, a little bit of energy, you know? I'm just up here shouting. You guys are down there just kind of like, oh, I can't be bothered. No, come on. So 7.5, you can do basic maths. Brilliant. 3 minus 4.5. You can go negative maths. 3 minus 4.5. Come on. 3 divided by 4.5. Can do complex divisions. And 3 asterisk 4.5. Okay. What happens if we do 3 divided by 0? Error. Why is it error? You cannot divide by 0. Is basically the computer is telling you, what are you doing? Right? Like, what are you doing? So please stop it. Right. Order of operations. What's the difference if we type in A is equal to 3 times 4 plus 5 versus typing in A is equal to 3 times open brackets 4 plus 5 close brackets? Sorry? Type it in and tell me the difference in value that you get from this equation versus that equation. Come on. What's the difference that you get? Yeah, okay. So basically, the computer knows, I don't know, primary school mathematics and knows that if I have a bracket, I prioritize specific operations, right? So, you know, I'm going to start with 4 plus 5 and then do 3 times the answer of that versus doing 3 times 4 and then whatever that is plus 5, which is, you know, because that's about the operation. Does everyone understand that? Yeah. So whatever knowledge you have in mathematics in terms of how you type in an equation, Python knows. It understands as well. Someone was kind enough to teach it. Okay. How do we store a number in a variable? How do we store a number in a variable? Come on. How do we create a variable? What are the two things that we need? Number one, a name. Yes. What's it called? And number two, a value. Yes. So if I create my num is equal to 5, it's an underscore here. I don't know if you can see it. I'm just going to zoom in even more. My num is equal to 5. Yeah. So that's my variable, my num, and it's equal to 5, and A is equal to my num. So what is A equal to now? 5. Yes. Okay. See, you're getting it. It's simple, right? So it's so easy. It's getting to line. Don't worry. Don't worry. By the end of it, you'll be coding like an expert. Convert to a string. A is equal to str open brackets my num close brackets. What's the outcome? Same. Same. Same but different. Yes, same, but different. But still same. Okay, so what happens if you do str my num, which is 5, and do a plus 5 at the end? What does it tell you? Error. What's the error say? So, during an integer, it's basically telling you, my good man, I'm sorry, but we cannot add a string and a number together. Those are two different data types, and I don't understand. Okay, so a string is a text. So you cannot add a text plus a number. It doesn't make sense to it. Right? Does everyone understand that? So when we create this function, str and open brackets and put a variable in it, I'm basically telling it, change the value within this variable into a string. Everyone with me? Simple stuff. So what if we wanted to change it into an integer? Int, yes. Integers are whole numbers for those of you who are thinking about it. Okay, so type in A is equal to ABS, open brackets, my num. Actually, I'm going to zoom in even more. I can't. What does it come out with? Sorry? 5. Because 5 is the... sorry, one sec. 5 is the absolute number. Yes, that is correct. Right. What does A equal to tau 3, 2 do? Come on. 9. What does it do then? What does it say? 3 to the power of 2. What if we wanted to make it, what if we want to do our number to the power of 2. Yeah, so it will be a equals to power, open brackets, my num, comma 2, right? So it's just that simple. Okay, let's go on. What about a is equal to max 4, 6, 6, 7, 78, close brackets? What does that do? Guys, I'm recording this, by the way, so you don't have to just take pictures. 78, why? Yes, it's the maximum value. I'm just telling it, please get me the maximum value from a collection of values. Okay, what about min? Minimum number, yes. What about round 3.2? It rounds it, yes. So it would just round the number. See, you're getting it. Pretty simple, right? Okay, so we're gonna build a basic calculator. Just a basic calculator. This is where it gets a little bit more interesting. Bear with me. The first step, I want you to create 2 variables to store the inputs of the user. So I need you to create 2 panels, create a new Grasshopper node, by the way, and have 2 panels going into it. The first panel, where you connect it, instead of X, Y, and Z, just name one of them num1, the second one num2. And then when you go inside the code, type in A is equal to num1 and num2. Tell me what happens. Yes, why? Why? Okay, try if you add the numbers 5 and 8.5. What happens? So when we were creating our... Yes, that is correct. So basically what it's doing is, okay, I'm just gonna add this piece of text next to this piece of text, job done. Whereas you haven't told it that it's an integer, right? That it's a number. So how do we do that? Right click, type hint, integer. Do it. What happens? Okay. We could do it a different way as well. If we didn't have the hints, you could go and create int. So you could say a is equal to int open brackets num1 close brackets plus int open brackets num2 close brackets. That would work as well. So in Grasshopper, you can just give it a little hint, tell it it's actually an integer. It's basically the same as adding the function in front. You can also use a number slider if you wanted to. If you wanted to use a number slider, you can do that. And then the output would change automatically as you change the number slider, which is kind of cool. So basically, you just create this and it will work. Right, I'm going to go move on. Everyone okay with strings, numbers, and variables? What time is it? I'm just running. Okay. Is everyone okay with strings, numbers, and variables? Yes. Excellent. We're going to move on to something called lists. Similar but not restricted to shopping lists. So what is a list? What is a list? A list of values. Sorry, go on. Yeah. Okay. All right. Interesting. By the way, as we move along, it becomes more and more interesting. So, you know. So a lot of times you'll be programming in Python and you'll have a lot of data and you need to manage it and organize it. The list is basically a structure in Python that allows you to store information. So yeah, what else allows you to store information? Variables, right? Variables. Yes. When I originally made this, it was late at night, and I was teaching it on Saturday morning, so I was having a lot of fun. All right, so much like a variable, you have to do two things. You have to give it a name, and you have to make it equal to something, right? Give it a name and equal to something. It's easy, but it has a little trick. So instead of just being equal to anything, whatever you make into a list, it has to have square brackets. Square brackets indicates that that value is a list. Okay? So let's do it. So it's all about those things. So in order to tell Python something is a list, it needs to be contained within square brackets. Let's make our first list. Friends is equal to Max, Odin, Yusuf. What do we have here? Type it in. By the way, you can write whatever names you want. It doesn't really matter. I'm just, you know. Okay, so once you've done that, we now have our first list. The comma between the values basically separates them. It's just telling us, though, okay, so anything before a comma is one item on the list, another item on the list, comma, another item on the list. So how many things are in, how many items are within our list? 3 items. Yep, that's basically it. So what can we put in our lists? We can put numbers, we can put strings, we can put booleans, we can put whatever we want. Cool. Everyone's happy so far. I like it. Everyone's just like super happy. Okay. So what happens if we type A is equal to friends? Good. You've done it? Yeah. Let's see. Yeah. So what do you notice that's actually quite interesting? Let me do it as well. Whoops. I'm just putting random names, but it doesn't matter. So if I press play here, you know what I notice on the side? It says 0, John, 1, Harry, 2, Amy, right? What does that 0, 1, 2 mean? That's the index, yes. Remember we were doing indexes before? That's the index. It's an item on the list. It's just telling you, okay, so in index 0, so the first item on the list is John. Or in your case, Max, or whoever else you put on. I don't judge. How about a specific elements? So index, yeah, okay, we've done that. Cool, I'm ahead, a step ahead. Okay, so this is a new challenge. Output only the second element in your list. The only thing I want to have as an output on A is only the second item on the list. How do we do that? A little hint. Come on. I just want the second item on the list. I'm giving you a little hint there. It's called some square brackets. Yes. Is that the only thing that you do? So yes, say the whole thing. A is equal to inside. Yeah, but that's the second item on the list would be what? It should be 1. Yes. So, bravo. Give that man a cookie. So, there's 2 answers. The first one is A is equal to friends, open brackets 1, or A is equal to friends, open brackets -2. Why -2? It counts backwards, yes. So it's the second to last index. Cool. Everyone okay with that? Yeah? You're going to be using this a lot. Anything to do with lists is literally one of the most useful things that you're going to do in Grasshopper Python. So please pay attention to this. You can switch off later on.
No space between.
Yeah, no spaces. Okay, let's have a little bit of fun. What happens if we type in A is equal to friends, open brackets, 1, this is square brackets, by the way, 1, semicolon, is it? Colon, right? A semicolon? I always forget the difference between the two. Anyway, it doesn't matter, that thing. So what happens if you type this in? So what's the actual output? The last two. So you have 3 items on the list and you're telling it to start each week from this one onwards till the end. Okay, so from the second item to the end. Okay, what about friends is equal to open brackets 1 colon 4, what's this semicolon? I'm not entirely sure. Is this colon or semicolon?
That's a colon.
So semicolon is the one with the, yeah. All right, colon 4.
Arrange like 1, 2.
Not necessarily. Keep going. What does it print out? Yeah, but what does it print out? Yes, it prints out between 1 to 4. We don't have that many items on the list at the moment. Well, it's actually between 2 and 5, but basically, if you leave it blank, it goes until the end. If you don't leave it blank, it will come up to that point. So just come up to that point. You're just telling it where to stop. So what about if we do friends 1 is equal to Mike, and then A is equal to friends? What happens? We're basically telling it that you know this item on this list, yeah. Now it's that value. Now it's not that value. So if you do that and you say A is equal to friends afterwards, it should be Max, Mike, and Odin, I think, and Yusuf. Odin got the boot. Yeah, well, happens. Cool. All right, time to do some cool stuff with lists. Because we can. No other reason, really. All right. We need a couple of lists and we want to add a little bit more stuff into them. So how about we create 2 lists? So new, make a new file or Grasshopper node and make 2 lists. The first one is lucky numbers. What is the underscore in between? Is equal to 4, 8, 15, 16, 23, and 42. If anyone goes and plays like Lotto or something and wins by those numbers, I'm entitled to half. Now, the second one is friends, and just add about 6 friends, whoever you want. Add 6. Actually, no, don't add 6. Add exactly what's written there, because I'm gonna probably ask you to do some funky stuff with them. Just write what I have there. It doesn't need to be an enter here. Just still one line. It's just no room in PowerPoint. Well, you could have an enter, doesn't it? Everyone wrote that down? Let's move on. Okay, so let's see. What happens if we type A is equal to friends.extend, open brackets, lucky numbers, close brackets? Sorry? Yash. A is equal to friends.extend, open brackets, lucky numbers. What's the output? Come on. Guys, what's the output? Is it really that difficult to write? Friends to extend?
But no,
You have a list of lucky numbers,
Does it come up
a
with
list of friends. We updated the command.
Okay, if everyone's getting null, let's scratch that one, although I'm not entirely sure why. Let's go to the second one. Friend A is equal to friends dot append sigida. Forget about the first one. Sometimes Grasshopper Python has some peculiarities that work in Python code but don't work in Grasshopper code, but don't worry about it. A is equal to friends dot append sigida. This is very important, the append one. Super important. You're like, I guarantee anytime you write a code, you're probably going to use append. That doesn't make sense. Hang on. And why? No, this should work. Why is an append working? Hang on, let me see why it's peculiar. If I may. Okay. So, guys, I know what the problem is. So, if you, for whatever reason, and this is very peculiar, you have to tell that A is equal to a list, I think, and then it should be able to do it. If not, I have another workaround. Okay, so we have to say that A is equal to friends. So we just have to tell it that A is actually a list called friends, and then A dot append whatever it is that you're doing afterwards. And it works. So for whatever reason, Grasshopper in Python wants to first know that the output is a list before you can do a command to it. So instead of doing A is equal to friends dot append whatever, you have to do A is equal to friends and then A dot append that one. It should work with extend as well. So if you do A dot extend open brackets like my lucky numbers, it should work as well. I never knew that this was an issue, but I guess you need to define the output as a list before you can give it a command in Grasshopper Python. Right, does that work for everyone? So I'm gonna write it here as well. So it's good to update. A is equal to friends, and then do A dot extend numbers, and then A is equal to friends. A dot. So what happens when you do A dot extend? It adds the list together, yes, and A dot append. It just adds one item, that value, to the end of the list as another item. Okay. So good to know. It's probably going to be the same as this one as well. It's probably going to be oh, this is another workaround instead of you just change the list beforehand. But okay, so just do a dot insert 1 comma Adam. A dot friends should be above it. It's interesting that Grasshopper doesn't like that. So what have I done here? Friends dot insert 1 comma Adam, and then just do a is equal to friends. But what does that do? At what position? Second position. So at index 1. Okay, so I'm telling it to, instead of append, which just adds it at the end, I'm telling it to add it at a specific location. Cool. Let's move on. So we no longer like Odin. What happens if we do friends.remove Odin? It's a hard day to be Odin. Come on, what happens? A dot remove Odin. Oh, sorry. Well, whatever you want. Friends dot remove Odin and then A equals friends, or A equals friends and A dot remove Odin. Same thing. Come on, what happens, guys? Odin's gone. Yes, it removed Odin. It's like, no, thank you very much. What if we type friends dot clear? It clears the list. Type it in. Tell me. Yes. So basically, what we've done is we no longer have any friends. Sad times. Friends.pop. What does pop do? Come on, what does pop do? Yes, it removes the last item on the list. It pops it out, literally, just pop. Just the last one. Okay, so far so good. Remove, you need to indicate the specific item. Pop is always the last item. So, you know, if you just want to remove the last item on the list, just pop. No, it's just one last item on the list. We're going to move on to functions and definitions, the cornerstone of every program. No pressure. No pressure. So what are functions and definitions? Basically, it's a collection of code that performs a specific task. So if you have something repetitive that you want to do, right? Instead of writing the same piece of code over and over again, you create a function or a definition, and you store that code in there and then recall it. So you don't have to keep repeating it. It also helps you organize your code and cut your code into chunks. That doesn't really make any sense to you, but you'll see in a second. So in order to create a definition, create a new Python script, Python node. And in order to create it, we have to write the magic words called def. So DEF. It signals to Python that you're writing a definition. So there's a few things that you need to write. Basically, it's DEF plus a name, and then open brackets, whatever parameters or variables you want to have in. And then close brackets and add the code at the end. So there's a space between def and name. Okay. So if we go down here, if I want to have a very simple definition, it says like definition say I, and then if we press enter, it should have indentation, so it goes further in. So if you press the tab button, for example, return hello user. That's just how it works. We'll go through it in a second. It basically indicates it's the definition. So it's a function. You know how we wrote is upper open close brackets? It's that. So it's how functions are written. Okay. Within those brackets, you might have a variable. So for example, the replace had two variables. What you wanted to replace and with what. So it was open brackets, 1, 2 parameters. You'll see in a second. So the code inside the definition does not run. You need to call it. So if you were to run what we wrote down before, so definition, say hi, open and close brackets, and then return hello user, and then say a is equal to say hi. What happens? Oh, I'll write it with you. So def say hi, close brackets, and then return what happens? Oh, I haven't done it. Asia, what? What? Ah, yes. Yeah, you that. So this is what I mean about indentation. You see the difference in the spacing here. Basically, whatever is indented after definition is contained within that piece of code. If it's not, then it's not contained within it. Indentation. Don't make sense. Don't worry, we're gonna do it again. Don't worry. Okay, so what I've done here, I basically just run the code. Right. Guys, this is important. When you're naming your definitions, it all needs to be lowercase with underscores between words. Very similar to variables, but don't have any uppercases in this one. Just all lowercase. Okay. So you can add parameters. You can say hi, open brackets, and you add a parameter called name. So, and then you can say return hello plus the name, like we did before with the character age and so on and so forth. So when you call it, say a is equal to say hi, open brackets, you have to add the parameter. In this case, it's blind. And in close brackets, what happens? So, did you see what I've done here? It was throwing an error unless I press tab. So if I press play, it's going to be like, what? I don't understand. But if I press tab here and indent the action within the definition, it works out. So indentation really important. Everyone with me so far? Yeah, everyone created the first definition. Hello, Mike, or whatever other name you may have chosen. Hello world, I am new to coding. You know, whatever it is that you want to do. Right, okay, let's move on. Everyone seems to have gotten this. Everyone knows how to add a parameter. Let's make a new challenge. I want you to insert another parameter to our say hi definition. That's called age. Okay, so all you have to do is just add another parameter called age. and then change the definition to return the following statement with both the parameter name and age being set by the user. Hello, username. You are number, years old. You're getting it? You have some experience? So now we're gonna insert another parameter called age. So it's name. How do we add age? Sorry? Come on.
Say hi, and then brackets name, comma, age.
Yes, name, comma, age. Super simple. And then when you say return, you just change the statements to include that number. Come on. I'll give you 1 more minute to do it. This is simple. Okay, guys, we're gonna move on. There's a lot. Oh, why did you keep getting electrocuted here? A lot to cover. So very simply, all we've done is just add comma age to the definition. So we add another variable, and then when we're returning it, just says hello plus name plus you are plus age plus years old. And A, say hi, like, and 17. Everyone have that? Good. Sort of. All right. So what can we pass as a parameter within a definition? Anything, any form of information, integers, flows, strings, booleans, arrays, anything that you want can be placed within that definition. Okay, 5-minute break. We're gonna go into if statements. The moment we've been waiting for, a way to place some logic in this whole calculating machine of yours. So take a 5 minutes break, go to the toilet, have something to drink, whatever it is that you have to do. And then we'll come back and do some if statements. Yes, of course. You want to go here? Yeah. Okay. Yes. Okay, guys, take a seat. We'll continue. It's going to get a little bit more interesting now because you're actually going to be writing statements and if state like logical commands to the computer, and it's going to have to well, understand your logic, which sometimes doesn't work. Okay. Is everyone here? No. Where's Rudy? He's been referenced twice so far within this recording. All right, give it another minute, but get ready psychologically and so on. It's like, you know, honestly, what happened to cookies and jellies and all that kind of stuff? 7 years ago, we came up to the 8th floor of shut because they were all CPUs were sitting around. There was so much sugar there. Like, in all honesty, you keep diabetes training to sleep. Like, she's not joking. So this energy. We used to have like test runs. We'll come back and supply. Even easier for you. You know, it's junk food itself. Okay, we're gonna continue, and I like it to be pointed out in the record that I did wait for Rudy. I tried. Okay, so if statements. Let's think about the logic of your everyday lives. Okay, what happens every day? I wake up. If I'm hungry, I'm either hungry or not, right? I'll eat breakfast. Otherwise, I leave the house. If it's cloudy, I'll bring an umbrella. Otherwise, I'll bring sunglasses. If I'm at a restaurant, if I want the meat, I'll order steak. If I want pasta, I'll order spaghetti and meatballs. Otherwise, I'll order a salad, which is probably what your generation is going to be doing anyway, because you're not eating any sugar. So, does everyone understand what a logical argument is, more or less now? Yeah? Okay, let's see how we're going to write that in a code. The basis of an if statement is you have to give it a condition, whatever it is, you know. If that condition is true, you'll do an action. If it's not true, you'll either do nothing, or you can even make it do an action if it's not true as well. You can also give it a second condition. If that is true, do an action. If it's false, do another action. Even more conditions. If that's true, do an action. If it's not true, do an action. You can give a second condition within an alternative condition. So it's if statements within if statements and so on and so forth. But what's the basis of it? A condition. If it's true, do an action. If it's not, do something else. Okay? Everyone understand that? Okay. So far, so good. You missed the basis of an if statement. It's over. Okay. Can someone explain to Businor what the basis of an if statement is? Come on, shout it out. What do we need? Number one, a condition. Yes, okay. Then what happens? Do another action. Yeah, okay, that's it. Okay, simple. So how do we code it? We need to create a Boolean first, right? So create a new Python node and let's type is male equal to true. So we're creating, what is this? What is male?
Definition.
Variable.
Oh.
Definition. Oh, that hurts. That hurt me as a tutor. So yes, it's a variable and it's equal to, I'll zoom in, guys, sorry. So is male equals to true. So I'm creating a variable called is male and I'm equaling it to the Boolean value of true. So we'll write an if statement. If is male, column, press enter, this is indented. A is equal, you are male. Else, A is equal, you are not male. What am I saying here? You've already been referenced twice. I'm not going to do it again. So what am I saying here? What is if is male? Yeah, yeah. Is there a better way I could have said it? It's fine. We'll go through it in a bit. But if is male is basically I'm telling it if this variable is true. There's a much easier way to understand it. We'll talk in a bit, but that's basically what I'm asking. Then just say that you are male. Print this as an output. Otherwise, print this as an output. Does that make sense? Yeah? Have you written it down? Does it work? Good. Okay, let's move on to your new challenge. Yeah, if and else needs to be on the same indentation, and then everything else inwards underneath them. You're going to learn about indentations as you go through them. Trust me. So many times the code didn't work. I want you to create a new Boolean called isTall and make it equal to true. So a new variable isTall and it has to be equal to true. Then include in an if statement that if you are male or tall, to print out you are male or tall or both. If not, print out you are neither male nor tall. Remove the previous stuff. But keep the is male equal to true. You basically need is male equal to true and is tall equal to true, and then create an if statement that says that if you are male or you are tall, print out you are male or tall or both. Otherwise, print out neither male nor tall. Let's see if you can write it down. I'm challenging you a little bit because I didn't really give you the exact way of writing. I want you to give this up. If you are male or tall, come on, I'm basically giving it to you guys. Come on. Anyone done it? Anyone even close? You have 1 more minute. I don't know why I keep watching my watch. It just ran out of battery ages ago. Yes. It underneath it. Yeah, it's within the E, same line, same presentation. But underneath it, it has everything indented again. Oh. Okay. 5, 4, 3, 2, 1. This is the answer. Is male equals, okay, it could be true, it doesn't really matter. Is tall equals to true, and if is male is equal to true, or is tall is equal to true, or, I'm telling you, or, like you're saying it, if this or this, right, is equal to true, A is equal, you are a male or tall or both. Else, A is equal, you're neither male nor tall. You didn't get it? You didn't get it? Why are we adding? Yes, so I'm telling you, if this, remember how Mahmoud said that this equal is not a mathematical equal, it's just a reference point? This equal is mathematical. So if this value within this field, or this variable, sorry, is exactly this value, so, if this male is equal to true, it's false in this sense, or if this variable is exactly equal to this value, which is correct, then you do this. Do you get it now? Okay.
Don't even, yeah. Didn't even get rid of the true and equals, right?
You can get the true and equals, you can get, yeah, but I'm leaving it there because sometimes, when you have strings or booleans, you have numbers, for example. So, if Ismail was the number 7, for example, and you say, okay, if Ismail is equals 7, that's how you would do it, right? Right. Okay. You didn't know the or commands in between, right? But it's logical. Yes. So let's see how logical you are. I want you to do the same thing again, but instead of the conditional saying that it's either one or the other, I want both Ismail and is tall to be true for the statement to pass. And the statement is to say you are both tall or male. And then if it's not true, you are not male or tall or both. So the only difference is that we're changing the statements in the end. And instead of one or the other being the same, it has to be one and the other in order for it to be true. You know what I'm going to do? I'm going to go back to the previous code. Okay. So you guys can see how it's been written down. I'm not saying it's a bad thing. It's just what it is, right? It's just logical. If you're not one, you're the other. I don't. Okay. Did you guys manage to do it? Yeah. It's basically, it's super easy, guys. Come on. If Ismail and is tall, right? Instead of or, it's and. We want both things to be correct. It's like writing English. You know, you could put equals true and is tall equals true as well, but you know, it's whatever you want. Even if you didn't know the command for and, it's pretty logical, right? No, your logic needs to go. Okay, oh, wow. I need to update the jokes. Other keywords. Okay, so what's elif? Else if, yes. So instead of just telling it, if this is correct, do this action, otherwise do something else. You're telling it, if this is correct, do this action. If not, if this is correct, do this action. If not, if this is correct. You can add as many elifs as you want. At some point, some of you guys are going to get your hands on a CA model with a bunch of transition laws and rules, which is basically about hundreds of codes of elifs going down. Okay, it's basically the same thing. Now, what's important to know about the elifs is you'll start checking if this one is true first, and then that one, and then that one, and then that one. If you have 2 or 3 things that might be correct, you'll stop after it reaches the first one that that kind of works. Okay. Not important now, but yeah, interesting to know. So let's improve our logic a little bit with comparisons. So how do you compare numbers, strings, booleans, and such? Well, what's this? Shout it out, guys. Come on. I can only hear that group shouting, so I'm assuming the rest of you are lost and don't know what this is. Is that correct? Yes, yes, it's correct. You're all lost and don't know what this is. Okay, what about the second one? Greater than equal to. Yes. This one? This one? This one? This one? Not equal. Yes. Okay. Good. These are all conditions you can add to an if statement. You can tell it. If this is greater than this, if this is equal to this, if this is not this, or not equal to this. So let's build a better calculator. Remember how we made a calculator before? Let's make a better one. The more you know, the more the computer can do. Okay, so this will be a test of what you've learned so far. Create 3 variables. This will be inputted on outside the Python node through a panel, or because it's a number, well, actually, no, through a panel. And it'll be number 1 operator and number 2. So each variable should be an input into the Python code. Can you do that? Come on, it's pretty simple. Just create a new Python node and have 3 panels as inputs. Each one of them will be number 1, operator number 2. Sorry, I'm going to zoom in so that the back people at the back can see. Can you guys see it? Yeah, excellent. It's until 5. Okay. You can give it a type hint. What would number 1 be as a type hint? Float. You can give it a float to be a little bit more open, you know, have decimals. Number 2, type hint, float. Okay. And what about operator? So a float. So a difference between an integer and a float. Integer is whole number. So 1, 2, 3, 4. Float allowed decimal. So 1.506. If you have something that's an integer and you give it a number 1.5, for example, it would come out as an error because it says that's not an integer. Okay, so when you're creating a calculator, if you wanted to have decimal points, you need to have the inputs as floats as opposed to integers. Operators can be a string because you're basically going to type a piece of text and you're going to give it a conditional that says that if that text is this text, then do this. More or less. Did you type hint a number? What did you write in the panel? Type 1.5 in the panel. Into both of them, but you've okay, now it's fine. Basically, because you haven't given it any numbers, it's like okay. Has everyone done that? Has everyone created? Yeah, okay. So 2.0, right? An if statement that all the two numbers that are going to be variables coming in, you multiply, divide, subtract, and add, depending on what the operator input is. Come on, this is meant to be a little bit challenging. How do we know if we added a plus or a minus sign? How do we write it in the code? Come on. What's our input for operators? It's a string, yes, which is a panel outside the code. What are you going to write in that panel as an operator? Okay, let's just go with plus. We're going to do an addition, okay? So how would the computer know that you've added that? What if statement do you need to give it? Is equal, yes. If operator is equal to plus in quotation marks because it's a string. So basically, I'm going to tell it if this variable is exactly equal to this value, then A is equal to number 1 plus number 2. And that you're doing the same thing for all of them. Come on, you can do it. Remember the ellipse? Come in candy here. Ellipse, ellipse, ellipse. Okay, guys. Let's move on to the answer. I'll zoom in a little bit.
Else, else everything.
Everything else. So in this case, for else, I just said invalid operator, please use these ones. Equals, yes. Yes, 2 times equals. You'll be surprised how many times I've done that as a mistake myself. It is what it is. So what I've done here was a little bit of change. You can put sliders if you want instead of panels. That's absolutely fine. But yeah, that is the answer. Can you guys see it? More? Okay, more. Is that all right? See, this is why you don't sit at the back. So this is me being very kind, but you can tell someone something else if they're doing something wrong. Right. Everyone with me so far? So what have I done? I basically created, if we go down, I don't know what that happened. I created 3 variables, number 1, number 2, and an operator. This is multiplication. I put this as a string type here. These ones are integers. You can make them floats if you want to add decimal points. And if we go up, I said, so if the operator, so if my operator is equal, so it's exactly the same value as a plus string input, then the answer would be the first number plus the second number. If it's minus, it's the first number minus the second number. If it's times, it's the first number minus times the second number. If it's divided, it's this one divided by that one. Otherwise, the only thing that can go wrong is that you place that invalid operator. So please use these ones. Right? Is everyone with me so far? Okay. Let's move on a little bit. Oh, yeah, indentation. So if we go here, can you see how the action is always indented under each one of the ifs, ellipse, and else? That's super important. Also, don't forget the columns at the end. Common mistakes. So who here has a working version of it? Okay, that's a lot of people without a working version of it. Yeah, you got it. Okay, good. Thank God. So after this, we're gonna move into for loops. Not sure if you buy loops, because I was afraid you're gonna break the computers. There's a couple of things that I've noticed that are actually quite important. The first one, we have to learn how to read errors. This is probably one of the most important things for troubleshooting what you're doing. So if I go here, right? Oh, we're still back here, okay. And I write friends is equal to open brackets max, and then A is equal to friends. What's going to happen? I don't know if I can zoom into this, but it says error, syntax error, unexpected token A, line 13. What does that mean? Unexpected token. This basically means that I was expecting something else to happen here, but instead you gave me this. So what was it expecting? The square brackets, right? So it's telling me that may go back. You forgot something. All right. Okay, so what if let's write an if statement. If friends open brackets 1 or sorry 0 is equal to max, actually it's the 1 equal. A dot A is equal to true. Else A is equal to false. Actually, no, all right. Okay, what is it saying now? Unexpected token equals in line 14. Why? What does that mean? It needs to be equals, yes. It tells you where the error is. Now, what if I do something like this? What does it say? Expected an indented block. You forgot to indent. So the computer will tell you here where the error is, the line, and what the issue is. Does everyone understand that? So when you're playing around writing code, it's very important to know what went wrong and where, and you try and troubleshoot every single one of them. It wasn't part of what I was going to teach you today, but actually it's super important, which I should probably add at some point. Okay, so how much time do we have? 40 minutes. Right, I think I think we're going to run through 4 loops and then end for today. So what is a for loop? It's the last piece of the puzzle for today. Okay, so it wasn't meant to be, but I guess at some point it was. What's a for loop? Anyone know? No. Okay, so Phil?
This is never benefit and there's like all this bunch of statements. So let's just condition is to it will keep checking in a loop.
For allows us to loop through a specific condition. Okay, it's just looping. Okay, so while is it there's 2 things. There's for loops and while loops. If you have a while loop, it will keep looping until a certain condition is met. A for loop is it will keep looping for as many times as I tell it. Okay, we'll go through it. We'll understand it. So it allows us to loop over a collection of items. Okay, so very simply, the way that you will type it in is for whatever variable within a collection, do something. So let's write this down. A is equal to an empty list. So if I put square brackets like this, it means it's an empty list. For letter in Giraffe Academy, A to the append letter. What happens? What happens? Yeah? Yeah? So how does it look exactly? Yeah. Has everyone done it? Has everyone wrote down? Guys, I need a little bit of feedback. No? Okay, I'll give you a little bit more time. So A is equal to an empty list for letter in open brackets, Giraffe Academy, close brackets. Don't forget the colon at the end. Enter indented line, A dot append, open brackets, letter, close brackets. Come on. What's happening? You list them, right? Okay, so super simple. I'm telling it that for every letter, add it to a list called a list A. Okay, so for every letter in Giraffe Academy. Now, this is quite strange actually. Why didn't we have to set a variable letter beforehand? No, why didn't we have to set the variable letter? No, I haven't said letter before. I posted here. 4 letters, yes. So the way that you write it here is you don't need to set it. You're basically telling it for every variable within a collection of things. In this case, our collection is a string. Okay. So what it'll do is it'll break it down into indexes. 1 index, 2 index, 3 index, and it'll go. Okay, the first one I'm going to append the first is G. Then I'm going to append I. Then I'm going to append I. If it was a list and it had like 2 items, Giraffe, Academy, let's say, what it'll do is it will append Giraffe and then it will append Academy because it's 2 items within that collection. So it goes, what's my collection? What's the first index breaking down? So this 4 letter is basically 4 index within. It can be named anything, by the way. It doesn't have to be letter. A lot of people use for I, or because it's shortcut for index, right? You can name it for John in Giraffe Academy, or Han in Giraffe Academy, as long as this is referenced here, so that you're appending that index in here. It is John, it will still work. It doesn't matter. So A lot of the times when you read code, you're thinking, why, what does let's mean? Nothing, literally nothing, right? It's just, I wrote let's because it makes sense in this situation, right? Okay, so I want you to create a list of friends, add 4 of your friends' names to the list, and create a for loop that for every friend within that list appends the name of that friend in list A. So it's very similar to the example above that we had. The only difference is instead of having a phrase, Giraffe Academy, we now have a list. Hey guys, has everyone managed to do something? Yeah? Let's see what the answer is. A is equal to a list. Friends is equal to Jim, Karen, and Kevin. For friends in friends, A dot append friend. Could I put anything I want here instead of friend? Yeah, I could put anything I wanted to. For I in friends, for whatever in friends. A dot append friend. Did you manage to crash your computer? Oh, see, this is why we're not doing the while loop. Any questions so far?
We don't have to, so same thing, right? You use friend, you create the previous list, it's the same as, because what it does, it goes to find what friends is, it brings the list.
Guys, are you with me? Yeah? Okay. Last few pages. Let's look at some other examples. What happens if we write for index in range of 10, A dot append index? What happens if we write that? Come on, write it down. This is the last bit. For index in range 10, A dot append index. What's the outcome? Okay, 4. So what happens? Come on, guys. For index range 10, A dot append index. What happens? 0 to 9. Yes, it goes 0, 1, 2, 3. Why? It's for every item within range of 10. How do you start with range? It goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 items, right? And it just appends it. Okay, so what happens if we do for index in range 3, 10, A dot append index? Sorry? Yes, it goes in between from 3 to 10 and appends just those ones. So this is similar to how we're working with lists, remember? Okay. What about for index in range, open brackets, len, open brackets, friends, close brackets, A dot append friends index. It's actually quite interesting. What happens if we write this? What am I telling it to do? For every index in range of the length of the list of friends. So if I have like 5 friends, what would be this number? What would be the length of the list if I had 5 friends in it? 5. That's how long it is. It has 5 items. Okay, then I'm telling it to append. So it's going through 5 times and appending the index of every item on that list. So what would be that index? 0, 1, 2, 3, 4. It's only 5 items if there's 5 friends. Okay, I can see that you're waning down. So what do we use for loops for? We loop through arrays, strings, range of numbers, lists, all kinds of stuff. I'm not going to give you a challenge, but we're going to look at this piece of code. I want you to tell me what's happening. What is happening here? What does for index in range of 5 do? Come on. For index in range 5, it runs through this loop 5 times. Okay? That's what it does. For index in range of 5, it basically runs through 5 times. Right. If index is equal to 0, so that's the first run, what am I telling it to do?
Print.
Yes, so it'll print underneath first iteration. If the index goes to 1, and remember, the index changes. Every time I run through a loop, it changes. It goes up 1. So we'll do this, print the second iteration, third, fourth, and fifth. So what happens if I run this piece of code? What do I see when it prints out at the end? What do you think? You see the last iteration? Wrong. You see all of them. Because you'll run through. The first time it runs through the loop, you'll print this. The second time, you'll print this. The third time, you'll print this. And the fourth time this, and fifth time that. So what you'll have is a collection of these things underneath. Because it's looping. It's doing it over and over and over again. It's not an if statement. It's not like only the last one is correct. No, they're all correct at different times. So when it runs once, it does them, it prints them every time. So the first one it's going to print is this one, and that one, and that one, and that one. So it'll be a stack of them with that one first, and so on and so forth. Cool, that's it. That's it for today. Going on, at some point, we're going to look at other things. I'm not sure if I'm going to run it next Wednesday or we'll see. Because next Wednesday, I want us to get into form creation. We know if statements, we know for loops, we know how to create variables, lists, how to play with them. We can create anything we want. So next week, we're going to do some cool stuff. Hopefully, you got your heads around this few simple basic blocks. If we get the most complicated code out there, it's all based on these things. So you'll never find anything different. So variables, lists, strings, booleans, if statements, for loops, and so on and so forth. Cool. Anyone have any questions before we end? I can see you're all dying after 3 hours of coding. Well, I guess you have a newfound respect for Google coders now, huh? Good. Good job. Have a good afternoon. Enjoy your evening.